I'm going to be solving question 71 from chapter 18 of the Knight textbook. This question asks, an inflated bicycle inner tube is 2.2 centimeters in diameter and 200 centimeters in circumference. A small leak causes the gauge pressure to decrease from 110 psi to 80 psi on a day when the temperature is 20 degrees Celsius. What mass of air is lost? And then it says to assume the air is pure nitrogen. So first, since we want to find the mass of the air lost, we already know that we're going to be looking for moles using our ideal gas law, because moles can easily cancel out with the weight of the pure hydrogen, the weight from the periodic table. They can easily cancel out to give us grams, which will give us the mass of the air lost. So I've already gone ahead and written down our equation and rearranged it. And what we're going to want to do is start out by finding the absolute pressure. So in order to find absolute pressure, we can use the formula, which is just where the absolute pressure is equal to the initial pressure. So initially it was 110 psi. And then we want to add the atmospheric pressure from the outside so that we can get the total pressure that is acting on the system. So that is approximately 14.7 psi at sea level. So that gives us 124.7. And then we're going to convert our psi, which is pound force per square inch, to kilopascals to make this easier. So 1 psi is equal to 6.89 kilopascals. So we're just going to multiply 6.89 kPa to give us 860 kilopascals. And then we're going to do the same thing for our P2, which is after it had lost air. So that's 80 psi plus 14.7, which gives us 94.7. Multiply that by 6.89 as well to get 653. And then from there, we're going to want to find the diameter. So we're given the radius is 2.2. So diameter is always going to be half of that, which is 1.1 centimeters. And then we're going to want to convert that to meters by dividing this by 100. So that just gives us 0.011 meters. And then from there, we're going to want to find the volume. And since this is a circle, we're going to be using the equation V equals pi r squared, which is just the area of the circle. And we also need to multiply that by the circumference. So we get pi times 0.011 squared. And then the circumference was 200 centimeters. And again, we're going to convert that to meters to give us 2. And that equals 7.6 times 10 to the negative 4th meters cubed. So we have volume, and we have our pressure. R is a constant, and then T, it says it was a 20-degree day, 20 degrees Celsius. So we're just going to convert that to Kelvin, add 273 to give us 293 Kelvin. So now we can plug this into the equation, and since we have an initial and an after pressure, we're going to use the ideal gas law twice. So that just looks like we have moles on this side, so N1 minus N2 is equal to P1 V1 over RT minus P2 V2 over RT. So we can simplify these two fractions since RT is the common denominator. And we already know that we know that the total volume is calculated already. So we'll just multiply the pressures to the side. So that just, it looks like V on top, RT on bottom, and then P1 minus P2 on the side. So then we just plug in our values that we calculated. So V is 7.6 times 10 to the negative 4. RT, we're going to be using 8.31 since we're working in kelvins. Multiply it by temperature, 293. And then RP1, P2. This gives us 0.0646 moles. And then our final step is to cross-cancel the moles with the weight on the periodic table of pure nitrogen, which is 28 grams per mole. So just multiply this by the 28. Moles cancel, leaving us with 1.8 grams of air lost when the tire deflated.